Hello people and welcome to the stream. Why is the chat not there? As usual, technical difficulties as we start. But today we are going to work on this, which is a MERG DCC controller. And I think that this is probably the cheapest and most easiest controller to get if you want to get one, other than maybe using the HM7000 chips. So within the pack you get everything that you need to build this controller. This is one I have previously built already, so this is the second time I'm doing this. It's not the most easiest of builds to do. Hello Christopher, nice to have you on board. So as you can see inside here we've got all the little buttons. On here we've got the main ICs, if that's going to focus on there we go, as well as the things to put them in. We have the encoder knob, and these are spaces to go on the inside of here. This is the little port to go on the bottom, and we've got the sounder, the encoder itself, a couple of LEDs and a few other bits and pieces, as well as the circuit board. Hello Brian. Sorry for everyone that's just joining. This is a DCC controller that I've created that comes from MERG. It's called the Cab 2. Now this comes as part of a kit. To which you need to buy this half of this board here, which is the command center, and then this is the booster. Then in this bit I have the USB board, which gives you computer control, and then again a board that gives you 2 ports to connect going forward. I created this box and 3D printed it myself, as you can see. This controller does actually give you the same functionality as what the DCC Concepts what's it called? The power thing that tells you how many volts and amps you're using. Well, this actually has it built into it. On the booster here, on these pinouts, just on this connector here, there are different things that give you voltage reading, ampage reading. You can have 5 volts for a fan, and so on and so forth. In fact, actually that's this one here. This one here gives you options to put the LEDs surface mounted elsewhere, and other bits and pieces like that, switches and a few other bits and pieces that can be done on this one. Good afternoon, Smallwood Junction. Try and put this back together properly. Come on. There we go. And this just fits together. This gives you your programming track, and your track outputs, and this is your power in, and then obviously you've got controller input here and USB here, and the controller input is the same on either side. But this is what we're going to be building today. It's not too bad, to be honest, because it all comes with instructions. As you can see here, giving you very detailed instructions on how to do everything. So you just follow those, and it's just a matter of soldering all the components to this PCB. It's the basics of it, really. You do have to do a bit of electronic testing to make sure you've got power in the right places before you put like the major components, which are these two here. Obviously these are the ICs. Come on, camera. There we go. So these are the two ICs that have been programmed up, and then you've got the holders. So you put the holders in place first, and then you test points on here to make sure you've got the right voltage for things. So we'll start getting things set up in place. Move us to one side for a minute. How is everybody today? You would fry that. Oh, hey, you're a bit more clever than you pass on to be, I think, Brian. I need to remember which side we start with. So, it says start with the diode first on the bottom. And which side is the bottom? Oh, right, okay. So that's the bottom. So I'll put this in place. Screw that up. Screw that up. So we can see okay. Right, we start with the diode. This is a diode. Very small. This camera's going to actually focus on it. Come on, maybe not. We'll show it in this one then. So this is the diode. It's very small. As you can imagine, that's my fingernail next to it. Excuse my dirty fingernails. So I'll just fold it over like that. And then we look for diode D1 on the board, which is over in this corner here, which is just as usual when I normally clamp these boards in place. I've normally put them in the wrong way, so I can't actually access what I need to do. So we'll put it in that way instead. It's coming along, Brian. It's coming along, Brian. it's there at this present moment in time. Things have changed a little bit since I first did the plans on it. Get diode. The little black line, it's got to go towards the white line on the PCB. Got it through that hole, yeah. Splay the pins out on the back a little bit, as you can see. Now we'll just add a bit of solder. Where is the end? There it is. There we go. This is the solder I use. Oh, hang on. Some of the best solder I've ever used. Whenever I run out, I always would just reorder the same thing. So now we'll put some solder on here. There we go. Where's my cutters gone? I did a minute ago. There you go. We'll just snip the legs off. Brian probably would fry it on purpose, just because it's those 3 letters. You probably are right there, Christopher. So now we move on to the resistors. Now, as you can probably see here, everything is numbered R6, R3, R4, R5. And everything's stuck to this bit of paper with a little bit of sellotape. I wouldn't say you're that stupid, Brian, to be honest. I do apologise that I keep knocking the microphone. So, where are we? R6. Where did R6 go? that side, Graham. There it is. I've not bent that quite close enough to the resistor. Now with resistors I normally go around and I just put them all in and spray the legs out just like that on the back, and I'll go around and I'll put them all in and then I'll go around and solder them afterwards. So R3 and R4. So up there. Now that one didn't go very nicely, did it? It'll be fine. Hello Monsville. Thank you for joining the stream. Oh, sorry I keep knocking the microphone. Oh. So there's that one. Well, you've done your job there then, Monsville. Hello. Now we want resistor 5. R7. There it is. And there we go. And now I'll go through and solder all those in, you see. Just move this in a bit better. There we go. And we'll get to soldering. I'm building, Monsville, one of these. Hang on a minute, let's change this camera. I'm building one of these, which is a MERG DCC handset. Comes with all the bits and pieces to build it with. There's a kit form. You get all the bits on the resistors and all the other little bits and pieces and the ICs and all the buttons, as well as the little screen, which is in this little bag here. And then you have to solder all the components onto this PCB on both sides. And then hopefully it works. Hopefully. Just bear me 1 second, guys. I'm going to move this microphone so I'm not hitting it all the time. Alright, I think that's going to be a lot better. I don't know what the audio is if it's any different, but it's out of the way and I'm not going to keep knocking it now. So I'll bring you back down to this one. No night, Mansell. Thanks for popping in. Let's chop all the ends off. Now with this kit in particular, you have to make sure that you get as much off the back of these as possible. You probably just saw me actually nip that one off there a little bit more because it was too close to this one. Because everything is very, very close on this kit. It's one of the more difficult kits to build, I must admit. And the main reason for that being is this. Where's it gone? Is this here. Because you have to solder this in. And it has to go in to there. Oh, I don't think it's going to let me because I've got to take some pins off actually, if I remember rightly. Yeah, it's too long. You've got to take a couple off, but that ends up sitting in there as you can see. And then the screen, which I'll show you. Has also got those little pinholes in them, and that's what puts the screen in this position. But soldering all of those tiny little holes that are so close together is actually very difficult, but we'll get there. So there is no R7 to fit, right, that's okay. Yep, everything looks good. Right, now we move on to the ceramic capacitors. C7 and C8. Again, I do these the same as I did with the resistors. I put them through. As you can see with these ones, there are no longer lead, so these can go in any way round. So C7, that's these two up here. So we'll pop that in there. We'll bend those over just to hold them in place. Now we want C1 and C3. Well, there's C3. And C1 is there. And we'll bend those ones over as well. And then we go with the resistor network, which I think goes in this top corner here. So I'll just slide the board. Yes, it does. So this will be the first thing we'll do. And as you can see, it's got a little dot on one end, which indicates that it needs to go into the one with the square around it. So make sure we put that in the right way around. And we'll flip it around. Now I'm going to have to hold that one in place while I solder it. So what I'll do is get my solder to one side. We'll get a little bit of solder. We'll pop it on that pin there. And that should hold it in place. We'll just pop a little bit on that end one. Just like that. And that will hold it in place while I put the rest in. There we go. I'll slide it back up a little bit and we'll pop the solder on these. And if anybody else builds one of these kits, you'll always find that the ground wires take a little bit more heat than what the positives do, and that's because of the fact that obviously it's a ground and it's going onto a ground plane, so there's a lot more copper around that it's going to, which means you've got to heat it up a little bit more to get that center piece of copper to the right temperature. Because as most people that do a lot of soldering will tell you, temperature is key. It's one of the most important things. If it's not at the right temperature, it will not work. There we go. We'll go around and snip them off. Again, as close as we can to the board. Now even these little resistor pins, they don't look like they're sticking out very far. I don't know if you can see that. But they are far enough, look. I will need to snip them off. There we go. So now we've got VR2 and polarized capacitors. So I'm guessing VR will be in here, because I don't see it on there. Oh no. VR is the encoder. Oh no, VR2. So yeah, I haven't. Oh dear. Oh. Seem to have a missing part. Hey, not everybody's cut out for all these electronics. Not everybody wants to do it. Not everybody can be bothered to do it. I'm actually an amateur radio enthusiast as well, so I've got my full license. So I sort of enjoy doing this sort of thing. But I do have a slight problem. In that I do not have that variable resistor. That is a problem. Oh dear. Well, I'm just going to have to carry on without it. I'll just have to fit it at a later date. Oh, that's not very good. I only opened this kit today, so it can't have gone anywhere. Never mind. Alright, so we'll start with this one. Done that. What? I've got to lay this one down. Oh, what the hell? I do apologise about that. Put that in. Put this in. Ooh. The light's got to go that way. Same as before with the resistor network. Put a little bit of solder on the iron. One in one corner and one in the other. Just hold it in place while we do the rest. And again, we'll cut those bits off. This is where sometimes I like to just tidy them up a little bit. There we go. What the f... Oh. There's loads of stuff missing from this freaking kit, man. How the hell? Oh well. Well, this worked out well while it lasted, didn't it? Well, that worked out well, didn't it? I'm missing a capacitor and I'm missing a variable resistor. Lovely. Well, we'll have to quit that job for now then. It's a bit annoying. Put all these in there for now. Put these to one side. Well, it's going to be a bit boring, but what I'll do is I need to solder these up. Which is these. Now these are what you put on the side of your layout, so then you can run your cable between your controller and your baseboards. So I'll just solder these up and then we'll call it a day. What a waste of my time. Never mind. Well, at least I suppose you've got to watch a bit of soldering. I can show you this one working eventually once I've done this. I think. We'll see. just do this one instead then. This is pretty simple really. These come up through the bottom. Make sure I've got them the right way around. Yep. Solder there, solder there, solder there, and the same down the bottom there. So pretty simple really. Yeah, I know. The good thing about it is like that all I've got to do is just email them, and they'll ship out the bits that I need that were missing from the kit. And the other good thing is I'll be able to send them the stream and show them that like I haven't just lost them. I only opened it literally before the stream and emptied the bag onto the back of that controller. So in hindsight, maybe I should have checked it before I came on stream, but my last one didn't miss anything, and all of my other kits that I've built, which I'll show you in a second, were never missing anything. If I have misplaced them, they should be on this piece of side here, because I haven't moved, and like I said, I emptied everything onto this. Now I've just dropped stuff on the floor, but I emptied everything onto this before we started, out of the bag. So we'll see. We'll see. No, I'm not. Well, I was going to have a video out within the next few days, but nothing seems to have gone right over the last few days, because yesterday, was it yesterday? No, day before yesterday, my computer decided that it was just not going to let any drivers work anymore. So I had to reinstall Windows, and when I reinstalled Windows, I thought I'd backed up all of my DaVinci files from my video editing. Turns out I didn't. So I haven't lost all the footage or anything like that. I've just lost 3 weeks maybe worth of editing work that I'd been doing on the videos that I was preparing to get to come out. So not my time of year at the minute, I don't think. And work's getting busier as well, because I'm a delivery driver, so that's the time of year when we start to get very busy. Why is that not going on there? Come on. No. Come on. There we go. A little bit on there. And a little bit on there. There we go. That's it for them. That's all it takes. It's very quick, very easy. And that's now that bit built. I haven't put that one on very straight. Oh, look at the state of that. Look at the state of that. That was not very good at all. We'll sort that out later. Come on, Graham. I'll put these ones in first. Never mind. It's not the end of the world. Yeah, Chris, the video I was editing was the one from Get and the one from Locomotion the week before. Well, luckily I did do some preliminary renders of the footage that I was working with, so I should be able to just go through it and pick out the bits that I'd already chosen and just redo it. But it's all the voiceovers and stuff like that I've lost that I'll have to go through and redo, so then they'll not sound the same as they did before and stuff like that. And obviously everything that you say doesn't always sound the same the second time you say it. That one's a bit better. There we go. Is that one done? While I'm here, I might as well show you the kits that I've already previously built before. Let's go to this one. So this one's called a CAN servo. Now on this one you can run 8 servos through these ports on here. I did have a servo on here to show you guys. So this is the servo, and then these just simply plug onto these headers, and then these servos just cut one of these off a second. And this servo would go inside this housing. This housing goes together like this, and this goes in here like so. This piece then sits over the top like so. You then put a bolt through here, which I'll just pop this screw through for now, just so it holds it in place. So then you end up with this mechanism. Obviously that's going to fall out because it's not screwed in, but you get the idea. And then obviously you would bend the end of your wire, pop it through the hole, which my 3D printer seems to have a struggle with making holes. So then once that's bent over and put into that position, you've then got your working servo motor. So then I'm trying to hold all this together. So then as you move your servo, it moves your point wire. This is not mine. I've 3D printed these. Not very well, as you can see, but I've 3D printed these myself. I didn't create the design. I cannot take any confirmation for that. That was a member of our Model Railway Club that has come up with a design. He has designed these from the MERG version, which is this one. This is the original MERG design, which if I snip this one apart, now with this one also comes in 3 pieces like this one does. But with this one they've put that bit through there. Servo then goes through, I think it's the same way that way. Is it that way? Might be that way, I can't really remember. But the servo goes through this one this way. And then, yeah, because then you move. Oh no, that's right, yeah, that goes on the end of the servo arm like that. Get rid of that disc a minute. So yeah, so this, I'd forgotten, I've not used this one for a while. So we'll just get rid of these. We don't need that. We don't need that. We don't need that. And we don't need that. Right. So yeah, this one I think it goes through this way. No, I was right the first time. Through this way. And this arm sits on top of here, like this. and this has the same sort of idea, but as you can see the other one's a little bit better designed than this. I'm all thumbs and fingers here, man. So yeah, so that one goes through in there like that. You have a bolt that goes through this hole, and this one cups on the top of the servo motor, and then your wire then obviously also bends over, goes in this hole, comes through this hole here, which again this is too thick for, and then this will move backwards and forwards as this moves the opposite way. It's very hard to move this one without it all being screwed together, but you get the idea of like this will move backwards and I can't get it. Yeah, you sort of get the idea, but this is a lot better, a lot better. It is very clever. The guy who designed it is a very clever man. A lot better than I did. But yeah, this is a servo board. So this is what I'm using personally. This will control all my points. There will be micro switches that sit either side of here. So as this moves across, it will activate each micro switch. One switch will be fed back to this input here, because this is, as I was saying before, you get 8 servo outputs, which means 8 different points, or 4 double slips either way, or 4 three-way points, and then you have 8 inputs here to use as feedback to make sure that you can have generating maybe an LED on your panel that proves that motor has actually moved, or so on and so forth, or if you want to use computer control, which is what I'm using it for. And then the other side you can use to switch your frog, and this is actually wide enough that you can fit 2 switches on either side, which means that then you can have 4 double pole single throw switches, so you can alternate switch 4 different things at the same time while you're moving from side to side, which is very good, I think. Very good. But that's the servo one. But a layout control bus. Are we still working? Oh, yeah, we're back. Are we still there? Anyway, so this, yeah, this works through CAN bus, which means that it can run through a layout control bus, which means that you can link all of these boards together with one of these, and every time you push a switch with this board, it transfers out through 4 wires into 4 wires, and then it will move the servo. I had the spinning circle of doom on mine, so that's why I was asking. So then that gives you your control. So on this plug here, you have different various outputs and inputs and grounds, so that you can make a matrix of switches and LEDs of 32 LEDs and 32 switches, all from this one board. And then that would just plug in. So obviously this would be in your board, this would be connected to all your switches and things like that, and then this would be on the top part of your control panel. This would be obviously mounted to the base of your control panel, and then you can just plug them into each other. Simple. You do actually get another header here if you really want to use it, so you can just either use just wires that you can just go straight in there, or that is actually a 26 pin, I think it is, or 25 pin, 26 pin I think actually, sorry, 26 pin header, so that you actually have a 5 volt out if you need it for anything in particular, for driving LEDs or anything like that that are a little bit more power hungry. So that's those two that work in conjunction with each other. You can buy a version of this board which I have coming, which just has inputs and outputs. So these could be inputs for switches, these can be outputs for LEDs, or anything else. The inputs is what I'm going to use this for. Now this is a DCC this is a DCC block detection module. So you would run your feed to your track in here, back out of here, up to your, say, your red rail. Then your black rail would go back straight back to your controller, and this will pick up any current that is going through that red rail, and feed that back out through these pink wires. These pink wires you could then connect to the input of here, for instance, so that you could have these boards next to each other, and you could have, for instance, your feeds to your points in here, your so then this would go in here. So then every time there is a train on top of a point, you can say that that block is occupied, and then if you were doing automation or something like that, then a train controller or JMRI or so on and so forth wouldn't be able to switch that point because the block would be occupied. Things like that. They do many other different versions of boards as well, like I showed you in my box. So in here, on this side, there would normally be heat sinks or something along these to do this, because this center section actually completely comes apart, and has got a duct through the center. These are heat sinks that will go on these transistors once everything's finalized with this. So then that sits on top of there. Eventually they will be on there with some insulation behind them. They'll be thermal conductive but non-electrical conductive material behind these three, and the same with this one. As you can see, there's already, I'm not sure if you can just quite make that out in the background there, but just behind that, if I can zoom in. You can just see the grey behind it. Let's try this one. Oh dear. Yeah, you can see it in there, the grey behind the. Now that is thermally conductive but not electrically conductive. So it gives you the thermal transfer but not the electric transfer. And then on the other side of this, in here, this is it's about a 9 amp booster. So then you have your DCC signal comes out of these ports. In this case, it will go up through this hole, come back out, and it will go into this header here. This is your main voltage in, this is your track power out. This connector here will be programming track output, and then this is your CAN bus output. So this CAN bus output will then go up via this USB port, which gives you your USB computer connectivity for controlling your stuff through JMRI and so on and so forth. And then this is for output to the layout. So the only way I need to connect this to the layout is via one of these ports, which is very simply with one of these cables. So I would have one cable plugged in there, which would go to the bottom of my controller. then I would have my other cable plugged in there, and then this would go to what I've just been soldering previously, which is one of these, which would be on the layout, and then everything on the layout would be linked into this, and then I would just clink into there, and then that's everything in. Two cables, and it would be exactly the same from the control panel. From the control panel, you would have one of these on the outside of your baseboards, and you would plug that into there, and then the other end of this would go into another one of these on the control panel, into there, and then all your C-bus modules would connect into here. So for instance, this module here, those two, and for instance this module here, so you would have this on the baseboard, and then this would connect here, and then in your control panel you would have the cable to another one of these, and then this would be connected to this. So then the only cable between your control panel and your main baseboards is just this. Has anyone got any questions? If there's anybody still here. Well, unfortunately today's stream did not go to plan, but there we go. Well, there's not a lot we can do about that, is there? I would like to thank you all for joining me. It is a lot to take in. I've been researching it for over a year now, Brian. I know pretty much the whole ins and outs of it now. Up until a few days ago, there were still things that I was coming across that I didn't understand about the whole situation. I didn't realise there's different revs of different boards, and I didn't realise that certain ones had come out after certain other ones, and somebody else told me this the other day. No, it's only all available in kits, unfortunately. And you can only buy it if you're a member of MERG as well, which also costs to be a member. But at the end of the day, I'm not being funny. If I get the prices up now of how much these things cost compared to a normal DCC controller, right, so let's go for this one. So for this and just this half, as well as a connector, which I think is what comes with the, I think the cab comes with a control, with a thingy anyway. So for this part, which is just your DCC controller, is £36.24, just this piece. I've got a feeling, I'm not 100% certain on this, but I've got a feeling it comes with one of these. I'm not 100%, but I think it does. And then this is £37.34. So in total, for £36 and £37.50-ish, so say £70, you can have yourself a full DCC controller as long as you're willing to build them. So I think it is one of the cheapest controllers out there. Don't get me wrong, I think the Hornby HM7000 chip is also a very good low barrier to entry into DCC, because you don't have to pay anything for a controller. You just buy a £60 chip. Most people have already got a mobile phone, so they don't need to buy all these controllers, because then they can just use their phone rather than needing to spend hundreds and hundreds of pounds on a controller. Don't get me wrong, that it doesn't give you anywhere near the same sort of control aspect, I would say, as what a DCC controller does, but for the money you're paying, you really can't complain. Hi Clive. Fortunately, I'm coming towards the end of the stream because it didn't go very well. I'll show you how far we got. So we've got a few components on the board. Maybe if I, that's better, isn't it? So yeah, so we've got a few components on the board, but unfortunately there's some stuff missing out the pack. I should have 2 of these and I've only got 1. And there is a variable resistor which goes, where does it go again? I can't remember where it goes now. Oh, up here. Goes up here in this corner. But it's not there. So I'm going to have to email the guy that does all the things and say, hey, I'm missing these items. Yeah, you're right, Chris. That's exactly it. You know, and if you're willing to do the little bit of work, don't get me wrong, this connector on the top here that I was explaining about earlier, this one here, let's see if we can get a better picture of it. Yeah, this one is very difficult to do, very difficult, but it is doable. Where did I... See, I've put the screen somewhere now and I can't find it. Never mind. I'll find it. I'll find it. But yeah, never mind. But I've got one anyway, so, and this one works. And if I take this back off. Screwdriver. Can I do it? No. 2 seconds. So this gives you an idea of the inside of it. As you can see, this is the VR one that I'm missing, and this is the other capacitor I'm missing. And that's what it should look like when it's finished, but obviously the other side's got all the buttons and stuff on it, and the encoder. I love that noise. Makes a very nice, satisfying noise. But hey ho, there we go. Put this back together so I don't lose that screw. Oh, come on. There we go. And there's that. So anyway, thank you very much for joining, everyone. Has anyone got any more questions at all? I would love to know why that chat's not working. Ah, there we go. It's finally decided to come alive. No worries, Brian. Thank you very much for everyone for joining anyway, and we'll hopefully catch you in the next one.